Okay, so welcome back. This video is we're going to talk about UV mapping, and it's for people who are maybe you're new to 3D rendering. Maybe you're using Blender. You just start out using Blender, and you're not quite sure what this UV mapping thing is, or maybe you've been doing 3D rendering for a while and you're still not quite sure what's going on under the hood. And you basically do UV mapping because you have to, and you press a few buttons and hope it looks reasonable. So what we're going to do is we're going to, I'm in Blender 2.8 now, and we're going to try and figure out what really is going on behind the hood with this UV mapping. And I'm going to use some animations and stuff to show, try and show what's going on to make it a little bit clearer. Okay, so we're going to start out in Blender 2.8, and I've got here my default cube that I loaded in, and I added a fancy texture just to highlight the faces. But I've got this cube, and if you look at it, it's kind of boring. It's just black with white edges. And let's say I want to apply a really nice texture to it to make it look like, say, a block of marble. Okay, so the first thing I do is I run out to the internet and look for a image of marble. And let's say I found something that looks like this, a beautiful marble image, and it's a JPEG or a PNG. And let's say I want to apply this image to my cube. So I need to figure out how I can apply this to the faces of this cube. Now, of course, the problem is, right off the bat, I've got a two-dimensional image, which is a JPEG or a PNG, and I've got a three-dimensional cube. So the computer doesn't know what to do with that. The computer doesn't know how you want this image to appear on the faces of the cube. Okay, so you're going to have to tell it, and you're going to do that by making a map, which defines to the computer what parts of this image appear on what parts of the cube. So to give you an example of, there's a lot of options on how you can do this. It depends a lot on the image itself. I mean, if you look at this image, it is probably, I'm guessing, like an image of a 2 foot by 2 foot or a 1 foot by 1 foot piece of marble. So how is that going to project or map onto this cube? Depends on the size of the cube and however you want it to appear. But let's look at some examples of how you might do it, some of the options, and what are the pros and cons of the different options. Well, first off, I could decide to take this image and scale it down and stamp it, the identical image, copy and paste it onto each face of the cube. So that's the identical image on each face. And I will get something that looks kind of like this. Okay, I've got each image, each face has the same image on it. And you can see, if you look at these two, that's identical image. So you might think, well, it's kind of the right size, but you know, somebody's going to look at this and say, hey, wait, you just duplicated these images on all the faces. It looks kind of goofy. So it might work. It might be in the background, and it might not really matter that you've got just duplicate images on every face. Or you may say, well, maybe I'll look at some other way to do it. So that's one option that you can do. You can just map the entire image. What else can you do? Well, you might decide that you don't want the identical image. You want to spread this image over all of the faces. So you're going to have to figure out, you're going to have to tell the computer, well, for example, I want this face to be mapped with this portion of the image. So I want to spread the image on all the faces, so maybe this face would see this part of the image and the top would see this part of the image. But you basically have to tell the computer how those areas of the image will be mapped onto the faces. And to do this, you use what's called UV mapping. And we'll talk about the UV part. But basically it's a map, and it's kind of like a street map. It gives you a two-dimensional image showing where you are in three-dimensional space. So you need to map this texture or image onto this cube. So let me give you an animation of what that might look like. So what I would do is I could spread this cube out into two-dimensional space and get something like this. And this would work, this cross-shaped thing would work as kind of a map to define to the computer, okay, on this face I want the image that is, we'll look at the image below. I want this part of the image to appear on this face, this part of the image on this, and so on. So you would then make a separate two-dimensional map that looked kind of like this, that defined what part of the image goes onto what part of the cube. Okay, so if I did that, and I gave it this map and had it mapped, I would get a cube that looked like this. So you can see that part of the image is appearing on this face, and this part of the image is appearing on this face, and so on. So that might be preferable because clearly these are all different parts of the image. You're not just repeating. So that might be fine, although you might think, well, the size is wrong. All right, maybe this is a 10-foot cube and this is an image of only a 2-foot square piece of marble. So maybe this doesn't fit. This size doesn't fit. So maybe instead of the mapping we just showed, you might decide to resize your cube and map it a little bit differently so it would look something like this. So what I'm doing is I'm making a map that's a lot smaller. I'm telling the computer basically, I want this face to be mapped by this tiny portion of the image, and this face to have this tiny portion of the image mapped onto it, and so on. So if I did that, I would get a resulting image or a resulting cube texture that looked like this. And you might say, hey, wait a minute, this looks goofy, it looks nothing like marble. And that's because we weren't considering the size aspect of the map compared to the size of the image. So it's really, really important that you take into account the image that you're mapping onto the object and the relative size of the object. Okay, so the two really big important things about UV mapping that people tend to disregard or not think about are the size, the relative size and proportions of the image versus the object you're mapping it onto, and also the orientation. And then, of course, there's the other extreme where you make the map very, very large. As you can see here, well, I've made the map very much larger than the image that I'm using as a texture. And what that's going to do is you can see you're basically telling the computer, okay, on this face, map multiple tiled copies of this image, and you're going to get something in your final cube that looks like this. And it's clearly unacceptable because it's just copies of a tiled image, and you can see the lines and you can see that it's just a repeat. So it's really, really important, again, that you check out the size and proportions of the object versus the texture and make sure that they are the same relative proportions and the same orientation, which means the rotation and everything else, so that it's the way it should be. And the biggest thing you need to do, and it's the thing that gets talked about the least, and it's one of the most important, is to use reference images. Now, you may think that you know what marble looks like and the relative sizes and everything, but you probably don't. And if you're really going to do some nice texturing and modeling even, you need to look at reference images to see how things are built and what their surfaces look like in the real world. So the last thing we're going to talk about in this video is, why is it called UV mapping? Well, the reason is because in Blender, in your scene, you have three-dimensional space, and everything is in terms of X, Y, and Z coordinates. But your image is only two-dimensional, okay? So since X, Y, and Z are already taken, they've decided to define the image space, two-dimensional, as U and V. So you've got X, Y, Z for three-dimensional and U and V coordinates for two-dimensional. And that's basically it. So every point on your image is defined as X or as U and V coordinates as opposed to X, Y, and Z. And that's about it. So thanks for watching. Take care and have a good day.